So now we are going to draw some angles in standard position when they're given to us in radians. So if you are comfortable sketching the angles in standard position in degrees, you could convert these to degrees and then sketch them in standard position. But we want to get away from that, okay? We're going to be using radian measure more than we're going to be using degree measure, and we really want to get comfortable with where it falls in the coordinate plane, okay? These fractional radian measures. Okay, so our first thing when we are doing any problem is just going to be to draw our XY plane. Okay, the same as when we did degrees, we're going to start on the positive x-axis, and we want to go 5 pi over 4. So I am pretty comfortable with fractions, and I'm hoping you will, if you're not there already, that you'll get there too. But whenever I am going to draw these, I am trying to get in terms of pi or 2 pi, because I know pi radians is half my circle, and I know 2 pi radians is my entire circle. Okay, so I would be able to see that 5 pi over 4 can be rewritten as 4 pi over 4, which is pi, plus another pi over 4. Okay, because 4 pi plus pi would give me the 5 pi when I have common denominators. Okay, that's how I can break up a fraction. So I am going to go pi units, and then I need to go pi over 4. I went pi radians, and then I need to go another pi over 4 radians. I know that that's about a quarter of the way. Okay, so this would be 5 pi over 4. Okay, it falls in quadrant 3. Okay, so again, positive angles move counterclockwise, and if you divided this into fourths, okay, you would go 1, 2, 3, 4. Oh, I'm sorry, my pencil's blocking you. You would go 1, 2, 3, 4, 5 fourths. Okay, I think it's a little easier. It's less counting, okay, to break up my fractions like this, but either way works. So 8 pi over 3. I can see that that is 6 pi over 3 plus 2 pi over 3. Okay, and 6 pi over 3 is important to me because I recognize 6 pi over 3 as 2 pi. Okay, so what I'm doing here is I'm either looking for a numerator that has the same denominator or a numerator that has twice the denominator. Okay, so I can see that this is 2 pi. So again, I'm going to draw my coordinate plane. Okay, and so I am going to go 2 pi radians around. And then I need to go another 2/3. So I remember that 2/3, right? If this is pi, 2/3 of the way around is right about there, and this falls in quadrant 2. Okay, again, if we had divided this into thirds, okay, we could see that we went 2 pi, and then we went another 1, 2 pi over 3. We also could have counted 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we would have gotten to 8 pi over 3. I just think that takes a little longer, and you know me, I always like to be efficient. Okay, for C, again, I'm drawing my coordinate plane. This time, I'm starting on the positive x-axis again, but I want to go in a negative direction. So instead of going counterclockwise, I'm going to go clockwise. Okay, so pi is half my circle. I want to go 2/3 of the way around. Okay, and I draw my arrow to show that that's the direction that I moved. And I can see that this would be in quadrant 3. Okay, let's look at D. Okay, again, I can see that this is negative 3 pi over 3 minus 2 pi over 3. Okay, again, I picked negative 3 because that's the same, the 3 is the same as my denominator, and I can see that negative 3 and negative 2, I want to keep these moving in the same direction, okay, that they'll add up to negative 5. So negative 3 pi over 3 is negative pi, so I'm starting here. Negative pi is 1 whole half circle, okay, that's pi radians, and then I need to go another 2/3. Okay, so this would be my negative 5 pi over 3. Okay, and again, I didn't do this on part C, but if you instead decided to cut these up into third pieces, okay, you could see that you went 1/3, 2/3, 3/3, 4/3, 5/3.